Why is the bond angle of sp3 hybridized carbon in methane 109.5 degrees? You can imagine that magnitude of bond. It's so big. Why? So, first of all, we need to know what methane is. Methane is CH4, having 4 bonds with hydrogen attached. And the question is saying, why is it that the bond between two bonds, the angle between two bonds is 109.5 degrees? Okay, these are the orbitals of carbon that participate in hybridization. 2p. So we have a spherical orbital, and we have p orbital that is dumbbelled in shape. So, this is a pair of electrons. It will be promoted to this empty p orbital, and we have something that looks like this. We have this. So, this is the s orbital that is spherical. These are the dumbbell-shaped p orbitals. So, in sp3 hybridization, one s we mix with p, and we are going to have a hybrid orbital. A hybrid orbital, or hybrid orbitals, formed as a result of mixing of this with this. And this is sp3 hybrid orbital. Each of them is sp3, 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 and so on and so forth. And the shape is like this, with unpaired electrons. Now, in methane, this is a carbon. That is the carbon in methane. Then these bonds, these orbitals, hybrid orbitals, are represented there with their unpaired electrons. Then s orbital from hydrogen overlaps with each of them. This is the overlap. Hydrogen, 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 hydrogen. And we have CH4, methane. Now, the question is saying, why these bonds? The bond angle, why is it 109.5? This is the reason. This is carbon. These two bonds are on the plane. The third one is pointing away from you. The fourth one is pointing towards you. And the arrangement is in a way that all these electrons, there's what is called electron repulsion. They cannot pile one side like this. You can't see something like this because electrons are negatively charged species. You can't see something like this because the distance between this and this is too close. Electrons are negatively charged, so they repel one another. So this arrangement is in a way that these electrons move as far away as possible from themselves, creating a very big bond angle between one bond and the other to be 109.5. You see? So these movement of electrons as far away as possible not only creates this bond angle, but brings about what is called tetrahedral shape of methane molecule.